Slope. In this lesson, you will graph proportional relationships, interpreting the unit rate as the slope.
A ski slope is a path for skiing. Some slopes are steep, while some are more gradual. We also use the word slope in math. We can represent a relationship between two quantities with a line on a coordinate plane. Slope is a measure of the steepness of a line. The unit rate of a line is another way of describing its slope. In this lesson, you will graph proportional relationships and interpret the unit rate as a slope.
Graphing proportional relationships. In math, we can describe proportional relationships with verbal descriptions, equations, tables, or graphs. Graphs help us visualize the relative change in two values. The origin is the point where the two axes, the x-axis and the y-axis, meet in a coordinate plane. When a relationship is proportional, we define it as crossing through the origin. To graph a proportional relationship, we need to know a point on the relationship's line other than the origin. That's because we need 2 points to draw a line. When graphing proportional relationships, the origin corresponds to the initial point. So, the origin is a common point when finding graphical representations of proportional relationships.
So without a second point, the line could go anywhere through here. But the second point means it goes through both of them, which makes it a straight line.
Proportional relationships are common. Any situation that involves a rate can be proportional. Here are just a few examples. The distance traveled by a vehicle moving at a constant speed with respect to time. The elevation gained by a mountaineer climbing at a constant rate with respect to time. The number of people a movie theater can hold per showing. The number of people who can ride a roller coaster in a single day. The roller coaster example depends on the capacity of the roller coaster. For instance, suppose a certain roller coaster holds a maximum of 20 people per trip. The number of trips it makes in a day determines how many people can ride it. You will explore this proportional relationship in the lesson activity.
Graphing proportional relationships. This activity will help you meet these educational goals. Mathematical practices. You will make sense of problems and solve them, reason abstractly and quantitatively, and attend to precision. Directions. The instructions for this self-checked activity, or read the instructions, type in your response to each question, and check your answers at the end of the activity. Write a brief evaluation of your work. Activity. In this activity, you will use tools such as verbal descriptions, tables, equations, and graphs to represent a situation. Question number 1. The Big Drop is a roller coaster that carries a maximum of 20 people per trip. Use this information to answer the following questions. Write a verbal description relating the total number of riders for the Big Drop, R, to the number of trips it makes, T. All right, so the verbal description relating to the total number of riders for the Big Drop is R to the number of trips it makes. So basically, if you take one trip, then the R equals, the R, or the number of riders, equals 20 times T. Well, then after 2 trips, right, R equals 20 T, but if there was 2 trips, then it would be R equals 20 times 2 for 2 trips. If the number of trips equals, let's say, 317, then R equals 20 times 317, the number of trips. The total number of riders is R. The maximum number of riders per trip is 20. The number of trips is T. So R, the total number of riders on the big drop, is equal to the maximum number of riders per trip, 20, times T, the number of trips. That means the statement R equals 20 times T describes the relationship between the total number of riders and the number of trips on the roller coaster. Using the description you wrote in Part A, complete the table relating to the number of riders to the number of trips. For Part B, using the description you wrote in Part A, complete the table relating the total number of riders to the total number of trips. This is just like you did in early elementary school, where you put a number into the machine, you did the function, and the number comes out something different. So 5 goes into the machine. The machine in this case is R equals 20 times 5. Here's the 5. Here's the 5. That's the number of trips. So you use your calculator. You say 20 times 5 equals 100. Like that. And then you keep going. So 20 times 10 is 200. 20 times 15 is 300. 20 times 20 is 400. 20 times 25 is 500. And 30 times 20 is 600. So 200, 300, 400, 500, and 600. So, using the description you wrote in Part A, develop an equation for the total number of riders in terms of the total number of trips. And we did that in Part A up here. R equals 20 times the number of trips. See? Riders equals 20 times T. The statement R equals 20 times T can be written as the equation R equals 20 times T. If you drew lines to the model the verbal statement, the equation, and the table that you created in the 3 parts of question 1, would you get the same line for all 3 explained? Because they all represent the same equation, then yes, all 3 would be the same line. If you graphed a line to represent the situation, what point would represent the unit rate? Because we know that the ratio or proportional relationship is 20 riders for 1 trip. The unit rate is 1/20. What is the unit rate for this situation? Be sure to include units in your response. This is essentially the exact same thing as this. We know that for one trip, equals 20 riders. So, 1, 20. With 2 points, you can define a line. Write 2 points that you can use to define the line that represents this situation. So I went up above and took information from the table that we made, and then I'm going to make them large enough to see. So if R equals 20 times 5 equals 100, and R equals 20 times 10 equals 200, we can use the point, we can flip it because it'll be easier on the graph, but it'll be the same line, I believe. Hopefully I'm correct. 5 and 20 and 10 and 20. And it would be shown as like this. But as we look at this, we can use any numbers from within the table, or we could use our own numbers that aren't on the table from above. For example, we could use the 0, 0. We could use 1 and 20, 2 and 40, 3 and 60, and so on. So, in theory, any of these would work. As long as you could put it on that table and put it into the formula or the equation, it will work to create 2 points. Point 1, point 2, point 3, point 4, point 5, point 6, and so on. Go to your math tools and select the graph tool to graph this situation. Set the window so that it shows y values from 0 to 100 and x values from 0 to 10. Then paste a copy of the graph in the space provided. For this next part, we're going to use a new tool. This new tool is over here in this Math Tools section. You click on this and it brings up the Graph tool. Now this was a little weird. You might have to play with it. And remember, this is a self-check assignment. So if you don't get it, check your answer and see why. Work at making your answer look like the answer that they give in the tutorial. But because you might have to do this on a mastery test, let me show you how I did it. So we're going to put in a linear equation. We're going to put best fit. Oh, we can't do that yet. Down here, we're going to put in the 20. And then we're going to add our data. So remember from the table, we had 0 and 0. Then 1 was 20. 2 trips would be 40 riders. 3 trips would be 60 riders, and so on. And then we click on plot. Now, this doesn't look right. This line isn't going through these dots. So I got to go back and figure out best fit. I don't know why. That's what happened. Now, see this black color? If I change it to red, it should make that line red. All right, so now we've got a red line going through. Notice that for every one rider, for every one trip, we have 20 riders. For every 2 trips, we have 40 riders. For every 3, we have 60, and it's a straight line. Then what it wants us to do, I don't know why that happened. I'm sorry. Oh no. Linear, best fit. Now I'm trying to get to the tool where we can copy it. We want to see our data points. Okay, so once I clicked that, then the data point showed up here, and then we can copy it out, copy table data. I don't know if that's going to copy the graph or not. We come over here, and in here we can do insert image. It says drag it there, so let's see. Oh boy, that's not right. Edit undo. Now I'm going to have to pause my video. All right, this next step says to go to your math tools and select the graph tool to graph the situation. Set the windows so that they show y values from 0 to 100 and x values from 0 to 10. I don't know if I did that already in this video because it took me so long to figure out the then paste and copy of the graph in the space provided. I don't know. So you come in here, you look at these tools here, you set it from the minimum x is 0, the maximum x is 10, the minimum y is 0, and the maximum y is 100. That's what the directions say. Click Save. In the relationship, it's linear, best fit, and I don't know where my data went, why I can't input my data, but I input the data earlier when I first came here. Let me see if I can do another graph tool, if it'll open up in another window. This is a pain. Maybe I should have pushed data first. I don't know. So I'm going to do it again. Data, 0, 0, 1, 20, 2 trips, 40 riders. 3 trips, 60 riders. It's following the simple formula from R equals 20 times T. So then we plot that. It's a linear relationship, best fit, and down here we put the minimum is 0, maximum is 100 per the directions. I just mentioned this, but it didn't let me put in the data, so I'm doing it again. That is all. 100, and then hit Save. That doesn't look right. Data 0, 0, 1, 20, 2, 40, 3, 60. Something's not right here. Oh, X is supposed to be 10 max. I messed up, but because I knew it didn't look right, I was able to fix it. In the lesson, if you don't know, you hit the show or submit and then show the answer, and you can say 100, 10, 0. It's kind of going up at a little bit. That one looks right. The other one before I found the 100 thing didn't. Okay, So now here's the tough part. They want us to take the graph. I'm going to use this one because it's smaller, easier for me to do what I'm trying to do, and copy and paste it. Well, I know how to copy and paste, but this thing is crazy. How you do it on a Chromebook is different. So we're going to have to skip this until we figure it out. But after about 48 minutes, I figured it out. So I hit the Windows button, the Shift button, and the S button. It pops up this little deal here where you do the triangle, or the rectangle, I'm sorry, I'm tired now. And you can highlight the area. Once it highlights the area, there's going to be a little thing pops up. Click here to mark up and share before it goes away. Again, I don't know that you're going to be able to do this on yours. So I clicked save. I saved it as a graph 1 to 20. That was the coordinates. I'm not going to save another one. And then I went to the assignment, and right here it says insert image. Then I went to the folder that it was in. You can do choose file. I drug it in. It doesn't matter. Find it wherever you saved it. And if it's not in the right JPEG, JPG, it won't work. So that's how you get it. It looks similar. 100. That shows 5 there. About 5 there. Okay, so it's close enough. Self-evaluation. How did you do? I couldn't use the tools in Edmentum. I had to Google it. It didn't work for the life of me. Even the video that I showed didn't work. So I don't know what I was doing wrong or whatever, but it didn't work. So there you go.
As you've seen, you can represent proportional relationships in many ways. You just created a verbal description, an equation, and a table to represent a proportional relationship. You also graphed that relationship. Now let's apply those skills to an entirely different situation. Henry leads a team of hikers for a full-day hike that takes 8 hours. Every hour, the hikers gain 250 feet in elevation. To describe this situation, first identify the two values that are involved. The independent variable is t, time in hours. The dependent variable is h, increased elevation in feet or height. Let t be the time in hours and h be the elevation in feet. A possible verbal description for the proportional relationship is h equals 250 times t. The equation corresponds to this relationship. H equals 250t.
H equals 250t.
We can construct a table based on the equation. This table shows the hiker's elevation every 2 hours from the base until the end of the hike. We can also graph the hiker's progress. The graph shows the increase in the team's elevation from the base to the end of the hike. The first point on the line coincides with the unit rate, the rate of increase in elevation of 250 feet per hour. Notice that the graph starts at the origin because the hikers started at base camp. Likewise, the last point on the line indicates the total elevation increase for the duration of the hike.
Okay. So this part here wants you to select the correct locations on the graph. Oliver is riding his bike to visit some friends. Every 2 minutes, so does this look like 2 minutes or does this look like 2 minutes? All right, so every 2 minutes he bikes 1,760 feet. So notice that the first increment, the second increment here is 1,760. Identify the pair of points you can use to create the line representing how far he has traveled in terms of time spent biking. Whew. So We know that when he started, it was 0. He didn't go anywhere, and no time had elapsed when he first started. So we're going to start at 0, 0. Then I know after the first 2 minutes, not the first minute, 1760, but the second minute, because it says every 2 minutes he bikes 1,760 feet. So 2 minutes, 1,760 feet. So those are my 2 points. That's where my line is going to go through. If you're just throwing random stuff on there, that doesn't mean anything. Explanation. Here it is. 1,760 feet every 2 minutes. So the point 2, 1,760 represents the distance he has traveled after 2 minutes. You can use this pair of points, 0, 0 and 2, 1,760 to create the line representing the distance he biked in terms of time. Oh. Interpreting the unit rate. That was smooth.
Similarly, for the other line, the point interpreting the unit rate. The unit rate of the graph of a line is also called the slope. Think of the slope as the measure of a line's steepness. A greater slope means a steeper line will form, and a lower slope means a less steep line will form. As you can see from the graph, the line with the slope of 4 is steeper than the line with the slope of 1/4. The slope of a line, or unit rate, is the rate at which the y value changes with a unit increase in the x value. For the line with the slope of 4, the point 1, 4 corresponds to the unit rate. Its coordinates indicate the change in y value as the x value changes. For instance, if the x value changes by 1 unit, the y value changes by 4 units. This unit rate gives us the slope of the line, 4/1. Similarly, for the other line, the point 1, 1/4, corresponds to the unit rate. Its coordinates indicate the change in the y value as the x value increases. If the x value changes by 1 unit, the y value changes by 1/4 unit. This unit rate gives us the slope of the line 1/4. In general, slope is the ratio of the change in y value to the change in x value. Sometimes we refer to slope as the ratio of rise over run. The video on the next screen explains why.
This is Daphne.
What's up?
Daphne lives to snowboard.
How could I not? Look at all that fresh powder out there.
If Daphne is going to get to all of that snow, she's going to need one of these.
A ski lift? Not really a news flash, Mr. Omniscient Narrator.
I'm trying to teach a math lesson here, and you just happen to be in it. Play along.
Fine. Then can I hit the slopes?
Sure. And thanks for the segue. It's time to learn about slope. Look at this graph. Let's imagine that it's the slope of the lift taking Daphne up the mountain.
I get to ride now?
In a minute. The x-axis is the horizontal distance. The y-axis is the vertical distance. And the slope of the chairlift, represented by the red arrow, is constant. So, for each foot you go horizontally, you go 2 feet vertically. The unit rate is 2 feet vertically for every 1 foot horizontally. Because the unit rate...
Now, why they showed it go run, then rise is slightly confusing. Because we know that slope is rise over run. It's just a simple way to remember it, but we go up 2 feet in elevation and over 1 foot. 2 feet vertically, and 1 foot horizontally. Vertical and horizontal. Horizontal like the horizon. It goes this way, not this way. Let's continue, brah.
Rate is 2, the slope of the graph will also be 2. The slope is the rise over the run, with rise being the y direction and run being the x direction. So, the slope is the change in y from one point to another over the change in x.
Cool. Can I ride now?
In a minute. I want to show how this slope relates to the lift you'll use to get up the mountain. Choose 2 random points on this graph.
How about 2, 4, and 4, 8?
Very good. Notice that the rise from the first point to the second is positive 4 in the y direction, and the run is positive 2 in the x direction. The slope is rise over run, or positive 4 over positive 2, which is the same as the unit rate 2.
So you're saying that the slope of the ski lift is 2 as I ride up the mountain?
Yes, based on the points you chose, but it's not just if you ride up the mountain.
What are you saying?
You could ride down the lift.
I would never do that.
What if you got cold feet?
Ha. Can we get to the point so I can fly down this mountain?
Fine. I'm just saying that if we show the slope from the top point to the bottom point, it's still the same. The rise and the run are both negative, so the negatives cancel each other out. That means the slope is still positive. The slope is the same for any 2 given points. What if you wanted to go higher up the mountain?
I'm listening.
If you went from point 1, 2 to point 5, 10, the slope would still be the same. One is 4 up and 2 right. The other is 8 up and 4 right. If we substitute these numbers for rise and run, we still get a slope of 2.
Nice. So I can take on these slopes now? Like the actual ski slopes on this actual mountain?
Be my guest.
All right. Expression for slope. This activity will help you meet these educational goals. Mathematical practices, you will make sense of problems and solve them and reason abstractly and quantitatively and attend to precision. Directions. Read the instructions for this self-checked activity. Type in your response to each question and type your answers. At the end of the activity, write a brief evaluation of your work. The graph shows how many cups of water are needed for each cup of flour in pizza dough recipe. In this activity, you will find the slope of the line shown in the graph. So for example, for every 2 cups of flour, you need about 1 cup of water. To calculate the slope, you need 2 points. Choose 2 points on the line. Doo-dee-doo-dee-doo. 2 points on the line. Don't think we can just click it? Nope, we can't. So the first point that I selected was right here. 0 and 0. 0 up and 0 over. The second spot on the line that I chose was 5, 3. 5 cups of flour for 3 cups of water. It says that the answers throughout this lesson activity assume the points chosen are 0, 0, and 5, 3. So I went with that. To calculate slope, you need to know the rise and the run of the graph. Use the graph to find the rise and the run from one point you selected to the other. So we have a rise of 3 and a run of 5. 5 and 3. 5 and 3. So, So between the points 0, 0 and 5, 3, there is a rise of 3 and a run of 5 units. Using the rise and run from part B, what is the slope of the line? So copying part B down here to part C, between the points 0, 0 and 5, 3, there is a rise of 3 units over a run of 5 units. So the slope is 3 over 5. Question 2. You can also find the slope without looking at the graph, using only the points you selected. Write 2 numerical expressions, one to calculate the rise and the other to calculate the run. Do not perform any operations, just write the expressions. So if we look at the numbers 0, 0 and 5, 3, 3 minus 0 is the rise. 5 minus 0 is the run. Back up here to our wonderful chart. 5 minus 0 is 5, the run. 3 minus 0 is 3. That's the rise. Write the numerical expression for the slope using the expressions you wrote in part A. We're going to have to use our equation editor to help us out on this one. So we got a big fraction. That was 3 minus 0 over 5 minus 0. Oh, whoa, not 35. 10. Did that get us down here? There we go. Got to make sure we're in the right spot. 5 minus 0. Then click OK. And that brings us in here. Don't know if we can make that big enough for everybody to see. Of course not. Oh, what if I drag it? There you go. Slope equals rise over run. Slope equals rise over run. Rise over run. Rise over run. Use the expression for the slope from part B to write a general equation for the slope of any 2 points, AB and CD. All right, so for this part, they want you to use the expression for the slope from part B. That's this here. And write a general equation for the slope of any 2 points, A comma B and C comma D. So slope equals D minus B over C minus A. To make this clear, I've did what it said, substitute A, B, C, and D in the numerical expression for the slope. So color coding helped me. So 3 is D minus 0 is B. C is 5 minus 0 as A. So it's a little hard to see down here, but they are showing D minus B over c minus a, which translates to the slope equals 3 minus 0, 5 minus 0. Slope diagram. Use the slope diagram tool to place the indicators on the 2 points you chose. What slope does it give? All right, so when you click on the slope program, it opens up in this and you click on slope, and then we can input the numbers. So the first was 3 minus 0 over 5 minus 0 equals 3 over 5. The slope is 3 over 5. We can see the rise over the run. 3 over 5. Now, this slope m equals y2 minus y1. y2 minus y1, x2 minus x1. So go back to our tutorial here, and it says drag the point indicators on the graph to the points that you chose in question 1. Observe the slope and the numerical expression for the slope on the right. So I'm going to write in big font 3 over 5. See? The simulation shows that the slope of the line is 3 over 5. What numerical expression does the simulation provide for the slope? Does it match what you found? So it gives us 3 over 5, and yes, that matches. Is that the right word? Matches? The numerical expression simulation gives the slope for 3 minus 0 over 5 minus 0. It is the same as the expression in part B. Self-evaluation. Let's move on.
Notice that this slope is the same as the slope in the lesson activity. To find the slope, we can consider any point as the first point and any point as the second point.
Oh, I'm sorry.
The rise is the y value of the second point minus the y value of the first point. The run is the x value of the second point minus the x value of the first point. We calculate the slope of a line using the ratio of rise over run. So, for any 2 points, x1, y1, and x2, y2, the given equation describes the slope. Slope equals y2 minus y1 over x2 minus x1.
Awesome. Now I gotta move on here. Where'd my tools go? Pause.
This is the general expression for the slope of a line. The equation works no matter which point is the first point and which point is the second point. If we reverse the order of the points from the lesson activity, 0, 0, and 5, 3, we would get the following for the slope. Slope equals 0 minus 3 over 0 minus 5 equals negative 3 over negative 5 equals 3 over 5. Notice that this slope is the same as the slope in the lesson activity. To find the slope, we can consider any point as the first point and any point as the second point, but we must keep the x and y coordinates of each point in the same order. That means we get the same slope even after reversing the order of points, as long as... Let's verify that the order of the points isn't important while finding the slope of a line. We'll calculate the slope of the line joining the points 2, 4, and 3, 6. Slope equals y2 minus y1 over x2 minus x1 equals 6 minus 4 over 3 minus 2 equals 2 over 1 equals 2. Let's verify that the order of the points isn't important while finding the...
Okay, so the y2 and the y1. What that's saying is this is the y-axis, and this is the first point, and this is the first y point. Or rather, they're saying, I'm sorry, x, y, I messed up. But the 6 is, sorry, I was correct. No, I wasn't correct. Let me confuse myself a little bit more. The 6 over 3 is the x, sorry, scratch that. The y2, it's the second point, minus the y1. So let me get back to Control, oops, sorry, Alt-T. Okay, so using our colors again. So y2 is y2 because it goes x, comma, y in our pairs. Let me change colors. So y1, y1, y1. Okay. Now x2 minus x1. So x2, x2, x2 minus x1, 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 x1. Whew. So 6 minus 4 equals 2. 3 minus 2 equals 1. 2 over 1. If we divide 2 over 1 in a calculator, 2 divided by 1 equals 2. The slope of the line is 2. Now, earlier they mentioned even if it was the other way around and it was a negative number, so we did 4 minus 6, 4 minus 6 equals negative 2. So even if it was negative 2, that's a 2, not a z, over 3 minus 2, I'm sorry, 2 minus 3, if we reversed it, 3 minus 2 minus 3, sorry, again, if we reversed it, it would be negative 1. Whew. Earlier, they showed that it didn't matter which way you did it as long as you did it in the right order. And what that means is negative 2 over negative 1, sorry, negative 2 divided by negative 1 equals 2. If you're ever concerned or think maybe you didn't do it right, check it out. See if it works. Part of this explains why a negative times a negative is a positive, or a negative divided by a negative is a positive. It doesn't matter whether you're going up and over to make 2 over 1, or down and over. -2 and over -1. Going this way is negative, going this way is positive. See, 1, 2, if we were over here, it'd be -1. If we were going down, it would be -1. So in the terms of graphing, the change, no matter which way you look at it, the change is still 2. That's why it's a positive number. The change is positive. Okay, Alt-T. Where's my cursor? Okay, there we go. I had to get my cursor back. So, I know that's a little confusing, but that's what they're trying to show there.
Now, let's reverse the order of the points to 3, 6 and 2, 4. Reversing the order of the points gives the same slope value. Slope equals y2 minus y1 over x2 minus x1 equals 4 minus 6 over 2 minus 3 equals -2 over -1 equals 2.
That's pretty much what I said.
That means we get the same slope even after reversing the order of points. As long as the 4 is above the 2 and the 6 is above the 3, the slope is the same.
All right. So this says type the correct answer in the box. If necessary, use a slash for a fraction bar. The slope of the line in the graph is blank. If your answer is a fraction, write it in simplified terms. So the first point that I labeled was 0, 0. And the second spot that I chose was 2, 3. 2, 3. Okay, so if we label the points x1, y1 for 0, 0, that makes 0, 0, or x1 as 0 and y1 as 0. So 0, 0. And then we look at x2 and y2 as 2, 3. The x is 2 and the y is 3. So on the x-axis, we go over 2 and up 3, over 2 and up 3. So then we put the 3 here and the 2 here, y2, x2. 3 over 2. So we type that in, 3 over 2, and hit submit. Correct. Then we clear out all of our junk here and move on.
A proportional relationships graph is always a straight line passing through the origin. To graph a proportional relationship, we need to know just one point on the line other than the origin. On a coordinate grid, the origin corresponds to the initial situation of a proportional relationship. The slope of a line is the unit rate of the proportional relationship and is a value that expresses the steepness of a line. The higher the slope, the steeper the line. The slope of a line also tells how much the y value changes with a unit increase in the x value. We can find the slope using the expression rise over run. Understanding slope is important because we are often concerned with rates of change. For example, the steepness of a mountain is a rate of change, and that steepness can tell you how difficult the climb will be. Slope represents that steepness, so finding the slope of a line is a valuable skill to have.
Also, if you're underwater really deep and you try to come up too fast, and so you go up in elevation towards the surface, you can get something called the bends. It's from going up too fast with the difference in pressure. It's crazy. I don't know what it means. Congratulations, we survived. We completed the tutorial slope. Thank you very much. Cheers to your greatness. And if anybody figures out how to copy that graph over, please let me know. Thanks.